Okay, so I want to give you an example of how to find a frequency distribution and then take that into a histogram. And while I do it, I'll kind of make some comments about why we do all this and some reminders about things that you would have probably learned about when you were doing your homework. This comes from a handout from Mr. Jackson. He gave me a few of these and because I told him how great I thought they were, and he told me to go ahead and use them if I want. So first, when you're starting with this data, you begin with a pile of money. In this case, in other cases, it could be a pile of just whatever data, height or IQ scores or body temperatures or tests on an exam in some particular class. But at this point, it's pretty boring. And in order to find much out about it, we've got to organize it. And that's the intent of the frequency distribution, is it's going to help us organize it. And then we can do even more with that. We can start visualizing it with the histogram or other tools. So before I do that, I want to show you a little trick for gathering the data. I'm actually using OneNote 2010. It comes with the student edition of Office 2010. So a lot of you probably have this tool and you don't realize that you do. You can click on an image, and then you can right click and choose to copy the text from the picture. Then you can just paste it right back into the screen. What's cool about that is then you can grab the data and then Control C or copy and get an Excel sheet open and paste it in there. Now when it pastes, it doesn't paste it in individual cells, so you can't do it as what I want to show you until you go to Data, choose Text Columns, and separate them using the first option here by spaces. And then go ahead and close it. So what it'll do is it'll go ahead and separate them, and now these are all in individual cells, and you can do things like type equals max tab, or just do parenthesis, select the whole region, and then close the parenthesis or just hit enter, and it'll tell me what the maximum one is. Or similarly, min, select the whole thing, and then I got the minimum one. I'm going to need those two if I'm going to be able to find out the range. And I need the range of the whole set if I'm going to be able to find out the class width. Now let me step back a little bit and go back to the problem here. So it's pretty boring as it is, and we're going to try to break it up into class intervals, but we've got to decide how many class intervals. Now that's the hard part. When you're new at this, you don't know, even if you're not new at it, if you're just not familiar with the data and what kind of distribution you expect to see, you're not going to be sure what number of intervals to use. So we just will tell you in the homework and in the reading, we'll tell you we'll use 7 on this, or use 11, or use 5. But it should be clear that you're going to use between 5 and 20. 5 kind of at a minimum, so that way you don't clump all the stuff together too generally and then not see any sort of a distribution at all. 20, somewhere around the maximum, depending on how big your data set is, but you also don't want to spread it out so much that again it doesn't tell you very much. So I'll show you what we're going to use. We're going to use 6 because it's actually the one that he decided to put in the directions for his handout. But we could have used 7 or whatever, but we're going to use 6. Okay, and then he says to order the data with Excel. He probably meant to type it all in individually. I just showed you how you can find out the maximum and the min. That's what we really need the sorting for, because we're going to find the class width before we can build the whole thing. So let's go ahead and do that. So the class width, let's see, that's going to be determined by finding the maximum minus the minimum and taking that whole number, which is a spread of 65, dividing it by how many class intervals you want to have, and we're going to have 6, so I'm going to divide by 6, and now I've got 10.83. So I have to round up. That's a requirement here, because if I don't round up, you'll find that you won't be able to catch all that data. So I'm going to round up. That would be 11. So now I can have them be 11 wide. Kind of an awkward number. I was hoping it was going to be better. But I take what I get, right? So class width, here's how you get it again. It's the maximum minus the minimum, also known as the range, divided by the number of intervals. And then you round up. No matter what it is, you round up. So in our case, this is going to be 11. Then you begin with the smallest number, or just underneath the smallest number, and go up from there. So our smallest number is a nice round number of 10. And I don't know if you remember that, but that was when we figured out the minimum right here. It was 10. And so we're going to go from 10, add 11 numbers to it, which makes okay, I'm not sure what that was recording and not recording, because it kind of broke up for a second, but either way. So you check and see, is that 11 numbers? And it sure is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It seems weird because when you add 11 to 32, it makes 43. But you got to remember that you're using the endpoints. So being inclusive, you can drop one off. So we go 43 starts down here now. Add over would be so on, and I'll go ahead and just fill in the rest and make sure that it's not recording. Actually, I realized I should be telling you what I'm doing here, because there is a fast way to do this. You can either take the lower class limits, which are these, and add that class width to each one, or you can take the upper class limits, which are these, and add that class width to each one. I'll go ahead and use the lower class limits. And since I said I was going to make 6 classes, I've got 1, 2, 3, 4, 5 already done. Add 11 to 54, and I would have 65. Similarly, on the upper class limits, add 11, add 11, add 11. Keep going, and you'll get 64 and 75. And you'll notice that that did it. That by choosing the class width of 11, that covered all of our data from our minimum of 10 to our maximum of 75. And we were hoping to cover everything. All right, so those are the classes, class intervals, and you should really label them by what they're recording here. So this is these are dollars. Okay, so then you look through the list of all the money, all the dollars, and you're going to find out the frequency, or let's see, these are probably from people's different accounts. So I would say something like accounts or banks. You know what? I'm going to name these a little bit more specifically. We know it's money, but they were withdrawals. And they were withdrawals by bank customers. Okay, now here comes the fun part. We've got to find all of the withdrawal cash amounts that fall within the $10 to $20 range, and that's inclusive. So you can just use tick marks off to the side here. You've got 1, 2, and I'm just going down by columns myself because that's what I like. And so I'm going to make a bunch of tick marks or hash marks over here, and then I'll write them more appropriately over here. All right, and that's the number of counts that I got. So again, you can use Excel for all of this, especially if we've already got the text copied from the picture. And you should probably see this. You can select and then roll over the bar and scoot it over, and then you can stack them if you want. And the reason why that's nice is because if you do sort the data, it is a whole lot easier to make sure you didn't miss any numbers, and more importantly, that you got all the numbers in the right classes that they matched. So okay, so in order to do that, I will just do data, sort. I will not continue or expand. Make sure that your data has no headers, that's unchecked. And you'll see there that it sorted it. I know that it's not all the same formatting. It doesn't really matter. I guess if it bothers you all, if it bothers anyone potentially, I'll go ahead and change that. So now that it's sorted, it would have been a little easier to see that, you know, these all fall in the same class interval, the 10 to, oh, what was it, 20. And so you can see that there's 11 there like I got. Let me go back to mine. And I bet if I would have checked the rest, that they would have been all in the right spot. But that's what sorting will do for you. Whether you do it by hand or with some sort of technology, it will help you verify that they're all accounted for in the right spot. So one other thing you can do, though, to make sure that you've done things right is you can see if the sum of all these numbers, and this is their sum notation, so we might as well start using it, it's capital sigma of the data, meaning the x numbers, the variables, the list. See if that sum turns out to be what we knew that there should have been altogether. Now, by the way, what was that? Well, these are, there's 8 columns and 4 rows, so there better be 32 numbers. And if I add those together, I do get 32. Wait, no, I actually don't. If I add those together, I get 31. So this is a good demonstration of why you want to double check, because 31 means that there's some number I didn't account for. And I did, sorry, let me write the number down right there. I did mark them all differently, so I should be able to go back pretty quickly and find out which one I missed. That was easy, there it is. So I only counted 7, but when I went back through, I could see that I actually had 8 in this second class. All right, so that adds up to be 32, which means everything's good. Now I've got a frequency distribution, and from here I can do a, I can see that line there. So from here I can do a cumulative frequency distribution or a relative frequency distribution. So the relative one would be when I make this 11/32 either in the fraction form like I just wrote it or the decimal form. So, you know, I could write this as 8/30, or I could write 1/4 reduced, or 0.25 or 25 hundredths. So anyways, that's a relative one. And then a cumulative frequency distribution is what I get if I did, let's get another color here. If I started out with my 11 and then I changed the names of my intervals to just say less than, you know, so the first one would be less than 20. The next one's going to be less than 31, less than 32, sorry. So less than 21, because it's strictly less than 21 would mean all these numbers, but I don't look at those, I don't write it that way, I just write less than 21, hit 11, less than 32, and then I add up, so that'd be 19, follow that pattern, you know, less than, I'd get 24, 26, 28, and then 32, and I can see that I've matched the number, the total, so that's a cumulative frequency distribution. So all of those are just variants of the original frequency distribution. But now we want to create the histogram. So let's try that. Okay, so we're ready to make the histogram. I'm going to go ahead and follow the directions here. I'm going to make a histogram from the relative frequency distribution. And I'm going to label the top of each bar. Actually, I'll also label on the side. And then after that, we're going to answer one more question. Okay, there's a little bit of a technique we apply when we're not actually starting at 0. We crunch up the line a little bit right here. And it tells the reader that, it's just not starting at 0. So we start at 10 here. You can label by the midpoints. You can label by, the whole interval. I'm just going to set this all up. All right, so here's the label, and I'm using the lower class limits here, and you can see they're adding 11 each time, and that's using the class width. And then I've got to put in the bars using the frequency, and I'm doing relative frequency. So this first bar is going to go up to roughly 35%. It's actually supposed to stop at 34.37. So I'm going to just put it about right about there. And the next bar needs to start from exactly where that one finished. And it's supposed to go 25%. That was the 8:30 seconds. So let's see if I can get that right. And let me do the rest. And we really should label. So again, down here we were showing the balances, the withdrawal balances. In other words, the cash, the amount of money. And over here we were representing the customers. Okay, it probably has one more question here, doesn't it? It probably wants to know approximately what percentage of people from the sample make a bank withdrawal of $50 or less. Oh, and there's one more thing. We were supposed to label the tops of each bar. So let's go ahead and do that and then look at this. What percentage of people from the sample of a bank withdraw $50 or less? Now, since we remember that this is the money amount down here, we're looking for 50, which is right about there, and $50 or less. Well, so we're not going to include this interval right here. So I'll include from here to that direction, meaning basically all of this. And I'll just add up, I'll just combine those percentages. So let's see, my answer would be roughly 76%. That's how many people make less than $50 withdrawals. The majority, really, the vast majority of the people. And it kind of makes sense if you think about the way you do your own withdrawals. All right, so that is it. It was a very long, messed up video. I kept making mistakes, but take it for what it's worth. I'm just trying to help out. So, and I'm kind of tired. I'm sure you all are. Incidentally, even though I said I'm done, and you could have paused at any time and stopped at any time, I do have to say, what happens if you add up these values over here, the 34%, 25%? add up all those values that I used as labels. Now those weren't the exact values, because remember the exact values were the fractions that then I turned into decimals and then I rounded into percents. If you add all those up, I'll just cut to the chase, you get 101.1%. Now that's not possible, right? To have over 100% of your sample suddenly appear here. It just occurs from approximation errors. So you need to be you need to pay attention to that, because in chapter 5 we have to draw really distinct lines between whether or not we have the correct distribution based off of the requirements for a discrete probability distribution. Anyway, I'll talk more about that later, and we'll see you later.